Welcome to linear regression. In the previous video, we have already seen three examples of problems that can be answered or can be analyzed using linear model. For this video, we will discuss about data types that commonly used or commonly found in linear regression. So, why we need to know about data types? The reason is that later on, when we do modeling, in order to be able to propose a good model, a model that can fit the data really well, we really need to understand the behavior of our data. The behavior or the characteristics of the data can be assessed when we know what is the type of our data. By knowing the types of the data, we can decide on whether the data that we have, let's say the number, the measurement, is it really the real number or just an identity, like the number is not the number itself but just representing something else, or is the number is based on some real measurement that we can do some mathematical operations on it. Different types of data requires different kind of treatment. So that's why before moving on to how to analyze data using linear model, we need to understand about the type of the data that we will be working on. So there are four types of data. Starting with the simple one, the simplest one is of the nominal scale. And then on a higher level, the nominal is an ordinal scale. And then an interval scale. And on the highest level is of the ratio scale. What are the characteristics of these data types? So the nominal scale is just some kind of categorical measurement. So in the nominal scale, we have data like category R, category B, category C, and so on. And in each of the category, they are on the same level. No category is preferred over the other, or one category is higher than the other category. It's not something like that in the nominal scale. They are just on the same level. Why? On the ordinal scale, we already know or we are introduced with a ranking system. So we know that one category is higher or more preferred than the other category. So ordinal scale is still a categorical data but already have the ranking or the ordering. So then we can just, for example, want to simplify our data. From ordinal, we just ignore the level of the category, so we just treat all the categories are considered of the same level. Then the ordinal scale is downgraded into a nominal scale. We can do that. Depends on what information that we want to get from the data. However, we cannot change nominal data into a higher order scale like ordinal data. We cannot do that. While the interval is already have the ranking, but the difference with the ordinal is that the ranking in the interval scale, it has equal spacing. What does it mean? By equal spacing, we will see it later on the example of interval scale. And the ratio scale, it has the true zero. It has an absolute zero, so that's why if for the ratio scale data, we can do any kind of mathematical operations, like for example addition, subtraction, division, multiplication. We can do that kind of things in ratio data, while in nominal or ordinal data we can't do that, because even if those data are represented by numbers, but those numbers are just the identity of one category and the other category, not really the real number, like what we can do the mathematical operation as in ratio or interval data. So now let's see some examples of the data types. So for the nominal data, some examples are like color, let's say eye color or hair color or skin color or fabric color, let's say red, blue, orange. All the colors are just have the same level. We don't say that blue color is much higher value than black color, for example. Also gender like male, female, I think they are just of equal position. No gender is above of the other gender. The type of environments like an example in the previous videos, and also the race like white skin or colored skin race, we think that they are of equal what is it position. So these kind of measurements are the example of nominal data. What about the example of ordinal scale? So let's, like what we said before, in ordinal scale it already has the ranking, so it shows the preference, or for example ranking of high school students, the first rank, the second rank, the third rank, and so on. But the rating of, or the rating of a survey, like how satisfied are you with your experience. Check 1 if you are unsatisfied, 2 if it's better than that, all the way up to 5 if you are very satisfied with it. These kind of measurements are called the ordinal, where one category is on top of the other category. Now let's see at the example of interval data. A very famous example is about the temperature measured in Celsius and in Fahrenheit. What we mean by equal spacing here is that the change or the length of the interval, or the difference between, let's say, the temperature of 45 to 46 is the same as the change from 100 to 101. The length of the interval from one value to the next value to the next value is of the same. That's what we meant by equal spacing. While, like in the previous example of the ordinal space, let's say like very unsatisfied to very satisfied, into the range, let's say we give a score of 1 to 100. Let's say for very unsatisfied, if we think like the score is between 1 to 60, while very satisfied is that from 95 to 100. So the length of the interval for one category is 60, while the length of the interval for the other category is just 5. So it's like different length. This category is this length, the other category is just this length. So that's for the ordinal, but for interval it's improved. They have the same length of interval from one value to the next value. Now what is the example for the ratio scale? Still with the temperature, but now is in Kelvin, because we know that in Kelvin it has an absolute zero. So that's why Kelvin is of the ratio scale. There are lots. Other measurements, that is of ratio scale, for example, like age, height, weight. So for this measurement, you can do mathematical operation. For example, we can say that a person of height 100 centimeter and a person of height like 150 centimeter, we can say that the second person is 1.5 times higher or taller than the first person. So those numbers really representing the mathematical operation. So that's why we say that those numbers representing the ratio scale.